to present to my lab next week. And this is unpublished data. Actually, this isn't really, I can't even really call this data because it's nothing new. I made it more fun though because I know that you guys hate science. So of course I keep you entertained. So
I'm ready to learn.
Bram, this is you.
My God, you've got my attention.
The self-McFarlane subtitles alive and well.
Rhythms. I don't know if you saw it on the last slide. Mock suppressor screen. I'm working with a gene called XDT1. I don't know what it is. Call zero. That's just a normal plant. Don't worry about that. I'm working with circadian clocks. You may know it because you go to sleep.
I don't.
And in plants, it doesn't do that. It does other things. Like this.
You did sleep.
You gotta go.
These go up and down. Isn't that cool? Yeah. No, they just go up and down like that. Do you know that they do this even if they're in a dark room? It's weird. And they do it in the light. I don't know why. And they also do this. More leaf movement. Look, it's so cool. Yeah, this is not. It's not that fast. I don't know. This is over 24 hours. It does every 24 hours. We live on Earth. Also pumpkins. I don't know. This one's less obvious. Isn't that cool? Wow.
Wait, the pumpkin also moves too?
That's the pumpkin growing.
The fuck?
Think of that.
Expand.
Does anyone have any questions?
Domain expansion.
Anyone?
Is this what people consider inflation?
I mean, I guess you could. I guess you could consider
If you
that.
want to find out
But you
more,
consider,
some
like-
pumpkin Halloween inflation or
No.
I guess if you're into that. You know. I'm not gonna yuck your yum. Alright.
It's getting too dark.
Anyways, what I'm doing, high throughput, yeah, back to the science. High throughput suppressor screen. That means we put a lot of seeds in, and I don't know, we get a small amount of results out. Design, this is boring. Randomly seed plates. So instead of putting the seeds individually, the seeds, mind you, are smaller than a grain of sand. It's incredibly tedious. I don't like it. I spent a lot of time doing it. Anyways, I'm going to mix them with portions of the wild type seeds, and it's kind of like I'm simulating what I'm actually going to do next quarter, which is mutate a bunch of plants and then look for this stuff. And it has like a 1% like success rate, so that's why I have to do like small percentages. Luciferin, that just makes the plants glow because they have the gene. Like we modified them so that they have the firefly gene, so they glow in the dark. But we have to give it this protein. And then I'm going to look for wild types based on how their clocks differ. So like the mutants have like a shorter clock, it's about 21 hours, and then the wild types are about 24 hours. Isn't that cool?
Much better.
And Peter again. Anyways, I did 3 mock screens over the past 10 weeks. So the first one, I did 6 plates with different amounts of seeds, and
Good
1%
God.
of the seeds was the wild type. And then the second one, I did 6 plates again, different amounts of seeds, but I did 2 different percentages. That way I can see the seeds easier. And then the third one, I did just 100 seeds on each plate at 1%, but I did 3 days of free run, which means I just kept it in the light for like 3 days without stop. Peter, we're gonna keep him there.
Please.
That was me. Hunched over the desk and plating seeds. Yeah.
Why do your shoulders look like
Have a
that?
control group? Yeah, the wild type.
I was wondering why you had MS Paint open.
Technically, the control group is actually the mutants, and then we're looking for the wild types. We're like purposefully mixing them, and when we mutate them, it's going to be random. So it's possible that we'll go through 10,000 seeds and not see anything. Isn't that fun?
That sounds so fun.
Anyways, this is what I get when I put them in the dark chamber and we image them.
The dark
And so you see them, they pulse every so often. And so that's them pulsing every like 24 hours. Each frame is like 2 hours.
Good
So,
God.
Jesus.
You know, so what I do is I look at that. Remember things. Anyways, what I do is I look at that, and then I look for the ones that are pulsing with each
Whoa.
other, and then I look for the ones that are pulsing out of sync. And so the ones that are pulsing out of sync have a different clock, and those would be the wild types. But I did like 1,000 seeds, and there's only like 10 seeds that are wild type. So it's possible that I go through all of them, and then there's no wild types, and I wasted all my time. And that's exactly what happened on the first one. Actually, I didn't. You can kind of see that those two are pulsing out of sync. Isn't that cool? Yeah, it's impossible as hell when you go through like hundreds of these. I don't have the data, but it would kind of look like that. So I did that in MS Paint. I have to find the data. I don't know where I put it. Anyway, yeah, so if you graph the lights based on pixel data over time, you get those sine waves, or cosine waves, or whatever. And then the different periods are going to have different phases. And so if they're shifted by 2 hours, then every 24 hours they're going to shift by another 2 hours. So eventually they're completely out of phase. Occasionally they'll sync up if you let them run long enough. This is the second one. It looks exactly the same. I know.
Wow.
Because I'm good at my job. But this one I got a little better results. Again, you can kind of see them going out of phase. So that's one wild type. So you can see most of them are pulsing in phase with each other, and then one of them isn't. This one I actually have the data for. It's
Real
very
graph.
gross. So to make it easier, you can kind of see those are out of phase. So I just isolated those two. So you can see that when one is up, the other one's down. That took about 4 days for it to actually get there. It was a very long time, and it wasn't very fun. But I'm getting there, I'm getting better. So this was the second one. Then I did a third one. You guys tired of this yet?
No, not at all.
I'm looking at the
Pretty much the
photograph,
same
so.
thing. It looks exactly the same, but all of them should have 100 seeds, except for that one at the top because I did my math wrong, and I didn't have enough seeds. And some of them also have more than 100 seeds, very obviously.
Are you being paid for this?
No.
Wow, that sucks.
No, I go there 3 days a week. Half the time I'm not actually doing anything. I just look at the data. And then the other half I'm growing plants. I have a bunch of plants in the fridge. I'm actually genotyping some right now with their DNA.
Very fun.
That's cool. Yeah, so these two, you can kind of see 2 of them are pulsing together, and then the one in the middle is out of phase. So that one you can kind of see
Good
here.
Lord.
This data is not very clean. I don't know what happened. Something happened. I have no idea. But this is the one that was different, so maybe that has to do with it. I don't know. If I plot
Bless
all
you.
of the periods on a thing based on the screen, I don't have the first screen because I'm lazy. I only had 10 data points. But you can kind of see most of them are around the same period, and then there's a few that are sort of above. So those are our possible wild types. Now, I did a lot of seeds, so we expected a certain amount of wild types. We did not get those. So for like the first screen, we expected 28 because in the first one, right, we have 3% seeds, wild type, and then we have different amounts of seeds. So in total, those add up to 10 or so. And the second one adds up to about 18. So in total, we would expect 28 over all 6 plates. We only got 11. There's like 39% match, it's pretty good. This third screen, though, we only did 6 plates, and each one was only supposed to have 1 seed. And we got 3, so that's 50%. That's pretty good. And in reality, we're gonna do like dozens of these plates for months. So it doesn't really matter. Future plans. I'm gonna finish with genotyping my wild types from the mock screen. So the ones that I picked out that kind of look like wild types, I'm gonna do those. I have them in the fridge right now with their DNA. I'm gonna do that on Monday. So I'll let you know. Then we're gonna actually, next where we're gonna metagenize them. I don't get to do that because it's dangerous. So my PI is gonna do that instead.
And put them in danger?
They're
She
expendable.
I would do it if I was allowed to.
Aw.
I think it causes cancer. I don't actually.
Oh.
I think it causes cancer if you're not safe.
Already
And
cancerous.
I'm not.
Okay.
I'm pretty safe.
It's okay, you're already
Think
at it.
I'm pretty safe, but I will say when I was spraying the luciferin on the plants, I got a lot on my gloves. So. Luckily, that's not dangerous. It's just yellow. Yeah, then we're gonna apply the screen technique to the actual mutated plants. This is very different from what they normally do. They normally place the seeds very individually and methodically, and it takes a long time, so that's why I'm doing it with just random plating and just seeing how fast I can do it, because we want a faster turnaround time. And then we're gonna genotype them, self them, and grow them for months, then keep growing them and selfing them and breeding them until we get a line of plants that are all the same. Isn't that fun? So that's what I'm gonna be doing for the next year. And then, I don't know, profit, I guess. What does it all mean? It means we don't have to plate the plants methodically. We can identify the clocks just based on visuals alone rather than having to graph the data every single time. Though we still graph the data every single time because it's just, it's a nice confirmation. And we can go through thousands of plants, but we don't actually have to check all 1,000 plants. We can just check like 20 of them. But what does it actually mean? I don't know. I'm not sure what any of this means. I'm not sure what